Hello everyone, good evening. So I think my voice is audible. This is lecture number 8 of linear algebra. So the last class we have started solving problems based on basis and dimension, right? I'll just show you the notes of previous class. So in the previous class we have introduced what is meant by basis of a vector space, and then we have introduced what is finite dimensional vector space, and then we have defined what is meant by dimension of a vector space, right? And then we have solved 5 problems of how to find the dimension and basis for the set of all vectors of Rn, right? You can see all 5 problems are based on show that the vectors, this is a set of all vectors in R3, right? So these three vectors forms a basis, and also we have solved another problem. I think yes, determine whether or not vectors forms a basis or not. So we know what is basis, right? A linearly independent set which is spans the entire vector space is called a basis. You can see all these 5 problems are based on vectors from Rn, right? You can see these are vectors from R3, and in fifth problem also these are vectors from R4, and again these are vectors from R3. So all 5 problems are based on how to find the dimension and the basis for the vectors involved in Rn, right? So in this class, we will do another 4 to 5 problems, again based on same topic only, right? We're going to find dimension and basis for the given subspace of the vector space, right? Okay. After that, in the next class, we will be proving one more theorem, dimension theorem, that is dimension of W1 plus W2, dimension of W1 plus of W2 minus dimension of W1 intersection W2. That theorem we'll do in next class. So this class will be of short duration. So we will do another 4 to 5 problems based on how to find dimension and range, and then next class we will continue more problems. Right. So this class will be of short duration. So we will complete some 4 to 5 problems based on basis and dimension. Okay. So this class, see, last 5 problems are based on finding dimension and basis for the vectors of Rn, right? R3 or R4. Now we're going to move on to another problem. This is problem number 6. I'll write on the problem, then I will discuss more, right? Okay. So problem number 6. Problem 6, right? Okay. So let A is equal to, let A is equal to, so given a matrix A, so which is 5, 7, 2, 1, 1, 1, minus 8 and 1, 2, 3, 5, 0, 3, 4, minus 3 and 1. So they given A, right? So they have given, find the dimension, find the basis and dimension, find the basis and dimension of the subspace, find the basis and dimension of the subspace B. So B consists of all those vectors x1, x2, x3, x4 in R4, such that A into x1, x2, x3, x4 gives a zero vector of R4, right? Gives a zero vector of R4. So we will do this problem, very interesting problem. So what they have said is they have given a matrix A, right? So A consists of a 4 by 4 matrices, right? So A consists of a 4 by 4 matrices. A consists of a 4 by 4 matrices. Here B consists of all those vectors in R4. That is a solution of this homogeneous system, right? Because we know homogeneous system is what? Homogeneous system is Ax is equal to 0 is homogeneous system, right? A is the coefficient matrix and x is the input vector. Now here you can see they are given as coefficient matrix. Only thing is we need to find the solution space. We need to find the dimension of solution space and we need to find the basis for solutions, right? That is, we will find the dimension and basis for the solution of homogeneous system. Comes under this comes under the problem called, we are finding the dimension of solution space of this homogeneous system, right? So whenever you see this, you have to understand this concept is based on finding 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 the basis finding the basis and dimension of the solution space of the solution space of homogeneous system, right? That is what it means, right? So they given A matrix, which is coefficient matrix. They are asking you to find all those vectors such that Ax equal to 0. This is nothing but homogeneous. Okay, the solution. So we will find the solution of homogeneous system first, and then I talk about basis and dimension, right? Okay. So they have given a homogeneous system Ax equal to 0. So to find homogeneous system solution, so we will form an augmented matrix A comma O, so which is 5 7 2 1 0 1 1 minus 8 1 0 3 5 0 0, and then 3 4 minus 3 1 0, right? So they have given a matrix. I have found an augmented matrix A comma. So we will reduce this to row echelon form. So first I will make this easy, as I'm just interchanging R1 and R2 equivalent to 1 1 minus 8 1 0. Then we have 5 7 2 1 0, and then we have 2 3 5 0 0, and then we have 3 4 minus 3 1 0. So what we'll do is we'll reduce this to row echelon form. See, we are finding the solutions of, first we'll find the solution of homogeneous system, that we already know how to find, right? In lesson number 3 4 we know how to find the solution of homogeneous. So we'll make a transformations. So R2 is transformed to R2 minus 5R1. R3 is transformed to R3 minus times R1. R4 is transformed to R4 minus 3 times R1. Right? So this transformation makes a given matrix as 1 1 1 1 minus 8 1 0. Now into 5, and then you subtract into 5. So 7 minus 5, this will be 2, into 5, this will be minus 40. So 2 minus of minus 40, so 2 plus 40, this will be 42. Now 1 minus 5, so 1 minus 5 is minus 4, this will be 0. You multiply 2 and then you subtract. You multiply 2, so and then you subtract. So 3 minus 2 is 1. You multiply 2 and then you subtract. So 5 plus 16, so 5 plus 16 is 21. You multiply 2 and then you subtract. So you multiply 2 and then you subtract, so it will be minus 2. You multiply 2 and then you subtract, so this will be 0. Now you multiply 3 and then you subtract. You multiply 3, so 4 minus 3 is 1. You multiply 3 and then you subtract. So minus 3 plus 24, minus 3 plus 24, 3 plus 21. You multiply 3 and then you subtract. This is minus 2 and this is 0. See how beautifully it is coming. Same entries. Now first row, first non-zero element. Below that everything is 0. Second row, first non-zero element is 2. We have to make 0 below element as 0. So we will make R3 is equal to, uh, we will make R3 is equal to 2 times R3 minus R2. So we will make R4 as R4 R4 as 2 times R4, 2 times R4 minus R2. So this makes the system as 1 1 minus 8 1 0, 0 2 42 minus 4 0. So into 2 and then you subtract, into 2 and then you subtract, into 2 and then you subtract. This makes as 0 0 0 0. Again into 2 and then you subtract, into 2 and then you subtract. So this also makes the entire row as 0, right? So this is in row echelon form. This is in row echelon form, right? Very, very important thing I'm going to say now, right? You need to find the dimension and the basis for solution space, not for these are not the vectors, right? If it is vector, then I can say dimension is 2. In the previous notes, previous class, I've said that if you want to find the dimension, the vectors of Rn only dimension is rank, but these are not, these are solution space, right? I'll give you more clarity now, just a minute. The previous class notes, I have said you that in problem number 1, the dimension of the vectors involving Rn is given by rank. See, these are vectors of Rn, but in our system, the we need to find dimensional basis for solution space, not for these vectors. So simply say that, simply don't say the rank is 2, so therefore dimension is 2. Please don't do like that. This is a solution space. For this is different. Or that it is rank is 2 means dimension will give rank. Dimension, to find dimension you find rank. But here it is a, you need to find dimension for solution space, right? I'll give you another formula for to find dimension, right? Just a minute. So you can see this in row echelon form. So first what we'll do is we'll try to find the solution space for this, right? First we'll try to find the solution space for this. So number of free variables, number of free variables, number of free variables is equal to total variables minus rank of A. Total variable is 4, rank of A is 2. So we have two free variables, right? So let us, we have two equations now, right? We have two equations now, x1 plus x2 minus 8x3 plus x4 equal to 0. This is first equation. And then we have 2x2 plus 42x3 minus 4x4 equal to 0. This is equation number, right? Now we have two equations. Let us assume we have two free variables, right? So let us assume x3 to be equal to k1, x4 to be equal to k2, and this k1 and k2 belongs to real number. We have two free variables, right? We can assume anything, those two free variables. Now from 2 we can find the solutions of other two involving x1 2x2 plus 42x3 minus 4x4 equal to 0. So if x3 is 2x2, so 2 times x2 k2, sorry, x2 we need to find, right? So what we can do is we can also divide by 2. So x2 plus 21x3 minus 2x4 equal to 0. So x2 plus 21 times x3 is k1, 2 times x4 is k2 equal to 0. So x2 is 2k2 minus 21k1. This is x2 solution, right? x2 is 2 times k2 minus 21 k1, right? Okay. And from 1 we have x1 is equal to 8x3 minus x2 minus x4. So 8 times x3 is k1, x2 is k2 minus 21 k1 minus x4 is k2. So 8k1 minus 2k2 plus 21k1 minus k2. So 8k1 plus 21k1. So 29k1 minus 3k2. So we have found k1. We have found solution space, right? The solutions. The solution is given by. The solution is given by x1, x2, x3, x4, which is x1 is 29k1 minus 3k2, x2 is 2k2 minus 21k1, and k1 comma k2. This is a solution space, right? This is a solution space. See, you can check this easily. You can check whether you can check easily whether our solution is correct or not. So let us, for example, Let us take k1. Let us take k1, k2 both to be equal to 1. You can take any number. Let us take both to be equal to 1. Then what about this? What about this new solution? 29 minus 3 is 26. 2 minus 21 is minus 19, and this is 1 comma 1. Now we see whether it satisfies these equations x1 plus x2 minus 8x3 plus x4. So x1 or in 26 minus 19, 26 minus 19, 1, 1. Okay, 26 minus 19. So 26 minus 19 minus 8 times x3 plus x4. So 26 minus 19 is what? 26 minus 19 is 7. So 7 minus 8 plus 1, which is 0. So it satisfies, right? And similarly, if you substitute here also 2 times x2. So 2 times minus 19 is minus 38. Minus 38 plus 42, which is 4. So 4 minus 4 is 0. So therefore our solution is correct. Now you can see this is a solution space, right? Now I can reorder like this as 29k1 minus 3k2 minus 21k1 minus 2k2 and k1 comma k2, right? I just rearranged k1 k2. Now if I take k1 outside, what you will have? If I take k1 outside, this is 29, this is minus 21, 1, 0, right? Because see, you just collect all those k1 terms from here, right? So here k1 term is 29, here k1 term is minus 21, here k1 coefficient is 1, here there is no k1, I'll put at 0, plus k2 times, just collect all k2 terms, minus 3, minus 2, here there is no k2, this 1. See, both are same, right? If I add, you will get this 29k1 minus 3k2 minus 21k1 minus 2k2 k1 plus 0k2 0k1 plus k2. Now we can see the solution space is spanned by these two vectors, right? Solution space the solution space is spanned by the vectors spanned by these two vectors, which is 29 minus 21 1 0 comma minus 3 minus 2 0 1. So the solution space is spanned by these two vectors, right? So how many vectors here? There are two vectors. This and also they are linearly independent. Also they are linearly independent. So solution space is spanned by vectors. Therefore, dimension equal to 2 and basis is given by these two vectors. So these two vectors alone will span the solution space minus 3, minus 2, 0, 1. Is it clear? Very, very important problem. How to find the basis and dimension for the solution space of homogeneous system. Very, very important. Right? Now I'll give you a formula. The you always note that the dimension of the solution space solution space of homogeneous system, the dimension of solution space of homogeneous system dimension of solution space of homogeneous system is equal to total variables minus rank of A. That's it, right? That is nothing but free variable. The number of free variable will give you the dimension. You can see how many free variables are there. There are two free variables. That means dimension will be equal to 2. You can from here itself you can have an idea what is the dimension will be, right? See here also we've said that these two vectors spans the solution space is spanned by the vectors, these two vectors, so therefore it has two linearly independent vectors. So basis is nothing but number of elements in the basis. Number of elements in the basis is dimension, right? Dimension is 2. I'll give you one more formula that the dimension of solution space is always equal to total number of free variable in the solution space. But there the dimension is rank. If the If your set involves only vectors of Rn, if your set involves solution space of homogeneous system, dimension is given by total variable minus rank of A. Um, just observe this, right? So you know how to find you know how to find the dimension of solution space of homogeneous system. Very, 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 very important idea. We will do one more problem based on how to find the basis and dimension for. Actually, this is problem number 6. So we'll move on to problem number 7. Next is find the find the dimension find the dimension and basis for the space W of all solutions of the following homogeneous system. Right? System is x1 plus 2x2 plus 3x3 minus 2x4 plus 4 times x5 is 0, 2x1 plus 4 times x2 plus 8 times x3 plus x4 plus 9 times x5 is equal to 0, 3x1 plus 6 times x2, 13 times x3 plus 4 times x4 plus 14 times x5 is equal to 0. See, this is same as the previous problem, right? The previous problem they haven't explicitly said that find the dimension and basis for homogeneous system. We have formed see the same thing. They have just given you an equation format. That's it. If you multiply A with this x1, x2, x3, x4, you will have four equations, right? 5x1 plus 7x2 plus 2x3 plus x4 equal to 0. They have given in equations form, right? So we need to find the basis and dimension for solution space of the following homogeneous system. So we will form an augmented matrix A comma O. So A comma O. So we can see how many there are five variables here, right? So 1, 2, 3, 1, 2, 3, minus 2, 4. And then we have 2, 4. See, this is homogeneous system, right? Ax equal to 0. A is the coefficient matrix and x is x1, x2, x3, x4, xy. So 2, 4, 8, 1, 9. Then we have 3, 6, 13, 4, 14. So we will try to reduce this to row echelon form. So R2 is transformed to R2 minus 2R1. R3 is transformed to R3 minus 3R1. This is equivalent to 1, 2, 3 minus 2, 4. Multiply 2 and then you subtract. You multiply 2 and then you subtract. You multiply 2 and then you subtract. You multiply 2, so 1 plus 4. This will be 5. Actually, we need to form A comma O. Okay. Um, we are multiply 2. So multiply 2 and then you subtract. And you multiply 3 and then you subtract. You multiply 3 and then you subtract. You multiply 3, so 13 minus 9, 4. You multiply 3, so this is 10. Multiply 3, this will be 12. And we have 0, 0. Right? This is not in row echelon form, so we need to make this element as 0. So R3 is transformed to R3 minus 2 times R2. This is equivalent to 1, 2, 3 minus 2, 4, 0. This is 0, 0, 2, 5, 1, 0. 0, 0, you multiply 2 and then you subtract. So this entire row becomes 0, right? So this is in row echelon form. This is in row echelon form. And how many free what is a rank? Rank is 2, right? So number of free variables, right? Number of, first we will find the solution space, right? Number of free variables is total variables minus rank of A. So total variables is how many variables here? 1, 2, 3, 4, 5. So we have 5 variables and the rank is 2. So we have 3 free variables. So therefore, what will be the dimension of the solution space? 3, right? Very important observation, right? Number of dimension of a homogeneous system solution space is given by total variable minus rank of A. So that means we have three free variables. So let us assume let us assume x3 to be equal to k1, x4 to be equal to k2, x5 to be equal to k3. So we can assume three free variables in our own. Let us solve for k1 and k2. So we have two equations now. x1 plus 2x2, x1 plus 2x2 plus 3x3 minus 2x4 plus 4x5 equal to 0. This is first equation. See, you know how to solve homogeneous system, right? Because we have watched lecture number 4 and 5. And then we have one more x1, x2, 2x3 plus 5x4 plus x5 equal to 0, right? So we will solve for x3, x4, x5, 3, x4, x5. Um, Okay, let us see. Already we know x3, x4, x5, right? Okay, so instead of this, what we'll do is let us assume x1, x2, x3. See, you can assume anything. Let us assume this as x1, x4, x5, x1, x3, x4, x5. See, we need to assume. We can assume any three things. So here, x3, x4, x5. Okay, let us assume. Let us assume x4, x5, x3. Okay, let us assume x2 as k1, x3 as k2, x4 as k3, so that I can find x. I know x4 and x5, x3, x4, x5, x4, x5. Let us assume x1 to be k1, x4 and xy to be k1, k2. See, you can assume any three variables to your own. So that means from 2, so from 2, 2 times x3, 5 times x4. So x4 is k2, x5 is k3 equal to 0. So 2x3 is minus 5k2 minus k3. So x3 is 1 by 2 minus 5k2 minus k3. And from 1, we have x1 to be equal to 2 times x4 minus 2 times x2 minus 3 times x3 minus 4 times x5. So 2 times x4. So x4 is k2 minus 2 times x2. So x2 is k. What I'm doing here. So x1, x4, x5. Okay, we need to find x2. Okay, so we have found x3. So we need to find x2 now. So 2 times x2 is equal to 2 times x4 minus x1 minus 3x3 and then minus 4x5, right? So 2 times x4 is k2, x1 is k1, 3 times x3 is 1 by 2 minus 5k2 minus k3 minus 4 times x5 is k3, right? So from this you can find you can solve this. So you will have this to be 4k2 minus k1. I'm just taking LCM. Minus 3 times minus 5k2 minus k3 minus 8k3 whole divided by 2. Just taking LCM, right? So 2, 2, and then you 2. So x2 is equal to, x2 is equal to, so 4k2 minus 2k1 plus 15k2 plus 3k3 minus 8k3 whole divided by 4. So minus 2k1 minus 2k1, 4k2 plus 15k2 is 19k2, and then we have minus 5k3 whole divided by 4. This is a solution. We can check this whether it is correct or not. So let us take x2, let us take k1, k2, k3 all to be equal to 1, right? Let us take k1, k2, k3 all to be equal to 1. So your x1 will be equal to 1, x2 will be equal to, if I take all to be equal to 1, we will have what? 19 minus 15 is 4, 4 minus 2 is 2, so 2 by 4 is 1 by 2, where x3 will be equal to, if I take 1, 1, this will be minus 5 minus 1, minus 6 by 2, this is minus 3, and x4 is 1, x5 is 1. I'm just checking whether I'm doing correct or not by observing the solutions. I'm taking a k1, k2, k3 all to be equal to 1. Um, so your new x1, x2, x3, x4 are 1, 1 by 2, 1, 1 by 2, 1, 1 by 2, minus 3, 1, 1, minus 3, 1, 1. Let us substitute here. So x1, so 1 plus 2 times x2. So 2 times 1 by 2 is 1 again, plus 3 times x3, plus 3 times x3, minus 2 times x4, 2 times x4, plus 5 times x5. So let us try to find this value. So 1 plus 1 is 2, 2 minus 9. So 2 minus 9, I think we are not getting the answer. I think we have made 6. So 2, 1 by 2, minus 3, 1, 1. So 1 plus 1 is 2, 2 minus 9 is minus 7, minus 1 minus 2 is minus 9, minus, I think I have made mistake. So I assumed x1 to be k1, x4, xy. So we have new system. This 2 x1, x2, x3 plus 5 plus x4 equal to, just a minute, I'll check this. So 2 times x3 is 5 times, a, actually this is x4, xy, I wrote, okay. So x4 is k2, x5 is k3. So 2 times x3 is equal to minus k2 minus k3. So x3 is 1 by 2 minus 5k2 minus k3. So x3 is correct. So 2 times x2 is equal to x4 minus x1 minus 3x3 minus 4xy. So x4 is k2 minus x1 is k1 minus 3 times x3. So x3 is 1 by 2 minus 5k2 minus k3, and x5 is k3. Yes, this is also correct. If I take LCM, this will be 4k2. This is minus 2k1 minus 3 times minus 5k2 minus k3, and this will be 8 times k3 whole divided by 2. So we will have 4 below. Okay. So 4k2 minus 2k1 plus 15k2 plus 3k3 minus 8k3. So minus 2k1. If I collect k2, we will have 19k2. If I collect k3, we will have minus 5k3 whole divided by 4. Okay, correct only. If I take k1, k2, k2 to be equal to 1, so this will be minus 5 minus 1 is minus 6, minus 6 by 2 is minus 3, and this is 1, 1 means 19 minus 5 is 19 minus 5. I think here I made mistake, right? If I take k1, k2, k3 to be equal to 1, so minus 19 minus 5, 19 minus 5 is 14, 14 minus 12, 14 minus 2 is 12, 12 by 4 is 3, sorry, x2 is 3 actually. I'm just checking whether I'm doing correct or not, right? If you are confident, you can stop here and get the answer. I'm just checking whether the solution is correct or not. I take k1, k2, k3 to be equal to 1. So x2 turns out to be equal to 3. Turns out to be turns out to be 3. So the solutions is 1, 3 minus 3, 1, 1. Let us substitute here. So x1 plus 2 times x2 plus 3 times x3 minus 2 times x4 plus 4 times x5. So this will be 1 plus 6 is 7. 7 minus 9. 7 minus 9 is minus 2. Minus 2 minus 2 is minus 4. Minus 4 plus 4 is 0. Therefore, the solution is correct only. Right? And similarly, if you substitute here also, 2 into 1 is 2. 4, 2 plus 4 into 3 is 12. So 2 plus 12 is 14. 14 minus 24. 14 minus 24 is minus 10. Minus 10 plus 1 is minus 9. Minus 9 plus 9 is 0. Yes, solution is correct only. So therefore, the solution space is given by x1, comma x2, comma x3, comma x4. So x1 is what? X1 is uh, x1 is k1. X1 is k1. X1 is k1. X2. So what is x2? X2 is here minus 2 times k1 plus 19 times k2 minus 5 times k3 whole divided by 4, comma x3, x3, x4 is given by k1, and what is x3? X3 is minus 5k2 minus k3 whole divided by 2, and then x4, x5. So k2 comma k3, right? Now if I take k1 outside here, if I take k1 here, let's write this as terms of k1. So k1 times here k1 is 1. Here k1 is minus 2 by 4. Here there is no k1. Here there is no k1. Here there is no k1. Plus k2 times here there is no k2. Here k2 is 19 by 4. Here k2 is minus 5 by 2. Here k2 is 1. Here there is no k2. Plus k3 times here there is no k3. So here k3 is minus 5 by 4. Minus 5 by 4. Here k3 is minus 1 by 2, 0, 1. See, when you add, you will get this, right? So k1, you will get k1 minus 2k1 by 4 plus 19k2 by 4 minus 5k3 by 4. So you have a second coordinate. Both are same only. So where this k1, k2, k3 belongs to real number. You can see the solution space. The solution space is spanned by above three vectors, right? So therefore, what is the basis for solution space? Basis for solution space is given by 1 comma minus 1 by 2 comma 0 comma 0 comma 0 comma 19 by 4 comma minus 5 by 2 comma 1 comma 0 comma 0 comma minus 5 by 4 minus 1 by 2 0 1. And what is the dimension? Dimension is 3, because you can see the number of elements. The number of elements in the basis dimension. You can see 3 vectors are there in basis. That means these 3 alone will generate all solution space, right? So see, already we know the dimension is 3, because the number of free variable will give you the dimension of solution space. That means the basis element will have 3 elements. What are those 3 elements? That should be found by this method. See, these two problems are based on finding the dimension and basis for solution space, right? Very simple. This is same as solving the homogeneous system problem. Only thing is you need to add these steps. You will just simply say that in finding solution, you will simply say that this k1, this k1, k2, k3 belongs to real number. You will stop here when you are finding the solutions, right? But here you need to do one more these idea, right? You have to bring in these ideas which are very simple and interesting, right? Now you know how to find the basis and dimension for solution space of homogeneous system, right? Okay, so move on to the last problem. See, this video is purely based on how to find the dimension and dimension and basis for solution space of homogeneous system, right? This is the core idea for this class. This is very important in exam point of view. So now we will do the last problem and then we'll wind off today's class. We'll do one more problem based on I'll give you one problem for exercise for you. Problem 8. You just comment in the comment section. Problem 8. Find the dimension and find the dimension find the dimension and a basis find the dimension and basis of the solution space W of some find the dimension and a basis of the solution space W of the system x plus 2y plus 2z minus s plus 3t is equal to 0, x plus 2y plus 3z plus s plus t is equal to, see, instead of x1, x2, x3, x4, xy, here they are given x, y, z, s and t, that's it. Tx plus y plus 8z plus s plus t is equal to 0, right? So you just take this exercise problem. It's same as previous two problems. Just how to find the just have to find the same method you have to follow. So instead of x1, x2, x3, x4, xy, here we have x, y, z, s and very simple, right? Okay, so this video is purely based on how to find the dimension and the basis for the solution space of homogeneous system. Next class we will continue dimension theorem, right? So thank you. This is next class.